Hi, solar energy students. My name is Yalda, and today I'm going to review homework assignment 1.4 with you. That was the assignment where you had to calculate what percentage of a country's area you had to cover to be able to supply its energy demand. Here I have already written down the data given in the assignment. You have a list of 5 countries with their areas given, the equivalent sun hours given, as well as their annual energy consumption. Now these sun hours per day show the equivalent hours that the sun shines with an irradiance of 1000 watts per square meters. So for the US, this is 4 hours per day with an irradiance of 1000 watts per square meters. And for India, this is 5 hours. Imagine you have a 270 watt peak PV system. Then the first sub-question asks, in which country would be best to place the panels to obtain maximum output? Now, if you understand the concept of equivalent sun hours, then this is actually a very simple question. Because of course, you would get the maximum energy output for the same panel if you place the panel at a location with maximum sun hours per day. Now, if you look at the table, the country with the maximum sun hours per day is India. Moving on to the second question. It asks the percentage of US area that you would need to cover to supply its annual energy demand if the solar panels have an efficiency of 15%. Now, to calculate this, you need to know 2 things. First, you want to know the number of panels. So you want to know the number of panels you would need to supply the annual energy demand. And second, you want to know the area per panel. So let's start with the number of panels. To calculate the number of panels needed, we need to know the yearly energy output per panel first. We know that each panel is 217 watt peaks and that it has an efficiency of 15%. The watt peak means that if the panel is irradiated by 1000 watts per square meters, this is STC, standard testing conditions, it would generate an output of 217 watts. Now in the US, we have 4 hours of 1000 watts per square meters per day. So on a yearly basis, a solar panel in the US generates, let me calculate this, 217 watts times 4 hours per day times 365 days in a year. And this gives us, if you calculate it, 394,200 watt hours per year. Now in 3 significant numbers, if you simplify this, this is 0.394 megawatt hours per year. The energy consumption in the US is given in megawatt hours per year also, and for the US, this is almost 4 billion. In 3 significant numbers, this is 3.89 times 10 to the 9th megawatt hours per year. So then dividing this number by the annual energy output per panel, you get the number of panels necessary. So let's do this. We have 3.89 times 10 to the 9th megawatt hours per year. This is the energy consumption. And we divide this by the energy output per panel, which is 0.394 megawatt hours per year. And this gives us 9.87 times 10 to the 9th panels. Now that we have the number of panels, you want to know what area they would occupy. And for that you need to know the area of one panel first. So you know that when 1000 watts per square meters falls on a panel, the output is 270 watts and that the panels have an efficiency of 15%. With this information, you can calculate the area of one PV module because you know that the 1000 watts per square meters times the area is the total incident power. So you have 1000 watts per square meter times the area. This is P in times the efficiency is the output power, which is 217 watts. Now with this you can calculate the area of one panel, and when you do that, the area of one panel is 1.8 meters squared. So then the total area for all panels would be the number of panels times the area per panel. Now let's do this. We have 9.87 times 10 to the 9th panels, and we do this times 1.8 meters squared. And this gives us 17.8 times 10 to the 9th meters squared, which is the same as 17.8 times 10 to the 6th, kilometers squared. Then you calculate the area percentage of US, which is the area of all panels divided by the area of the US. So let's do this. We take the area of all panels, which is 17.8 times 10 to the 3 kilometers squared, divided by 9.83, this number, times 10 to the 6th kilometers squared, times 100%. If you calculate this, you will get 0.18%, which is the area percentage you need to cover to supply the US's energy demand. Now the same thing you can do with all other countries, and the formula you're actually using is, if you want to calculate the area percent is energy consumption divided by the energy per panel. So energy consumption divided by energy per panel. You do this times the area per panel divided by the area of the country times 100%. Now remember that the energy per panel is different in different countries since it depends on the equivalent sun hours according to the following formula. So you have energy per panel is 217 watts times 10 to the minus 6, I'm going to do this in megawatts, times the equivalent sun hours times 365 days in a year will give you the energy per panel. Now if you do this calculation for all countries, you get these percentages. For the US, we already had 0.18%. For India, we have 0.11%. For Brazil, we have 0.02%. For Spain, we have 0.21%. And for the UK, sorry, we have 1.03%. Therefore, for the final two questions, the country with the highest percentage of area needed to supply its own energy demand is the UK with 1.03%, and the country with the lowest is Brazil with 0.02%. So there you go. I hope the assignment is clear now. Thank you all for listening and good luck with the rest of the course.